Hi, welcome back to the channel. So, if constructing a natural cubic spline has been a challenge for you, it won't be a challenge anymore after you watch this video. Okay, using an exciting example, I'm going to take you through step by step everything that you need to do to be able to easily construct um, a natural cubic spline. Okay, and I'll try my level best to make it super easy for you to be able to understand everything that we are going to do, such that you're able to do any other examples on your own. Okay, so the question that we are going to look at is question 11, and there, of course, there are two parts to it: question 11a as well as question 11b. And what we focus on in this video is question 11a. So question 11 itself says, given the data, f of 0 is equals to 0, f of 1 is equals to 1, as well as f of 2 is equals to 2. We have to construct the natural cubic spline S that interpolates this data. Okay, so the first thing that we are given is the fact that our f of 0 is equals to 0, then our f of 1 is equals to 1, then f of 2 is equals to 2. This is pretty interesting. So what this tells us is that your x naught is equals to 0, your x sub 1 is equals to 1, x sub 2 is equals to 2. So once again, if you observe, I have 0 here and I have a 0. I have a 1 here and I have a 1. I have a 2 here and I have a 2. Okay, isn't that interesting? Are we going to say this is the way it's supposed to be? Of course not. This is just some sort of a coincidence. Okay, so this can be any value here. It can have any value here. It can be anything. Okay, that's just an interval, and it's just a coincidence that you have a 0, you have a 0, you have a 1, you have a 1, you have a 2, and that's a 2. So that's just a coincidence. Okay, so we are going to remind ourselves of how we write more like um, the standard piecewise functions in terms of a natural cubic spline. So this is where you have your s naught of x um, as well as s sub 1 of x. Okay, this is equals to, here you're going to have your a naught plus your b naught, and this is supposed to be x minus x naught here for this part, which is b. But because our x naught, we know that it is equals to 0, we don't really have to waste our time there, so we can just put x there like that. Okay, that's our x plus our c naught is also supposed to be like x minus x naught to the power 2, but because this is 0, for simplicity and to save time, we can just write x squared, then plus d naught is supposed to be x minus x naught to the power 3, so that's just that would be d naught x to the power 3. So we have d naught x to the power 3, like that. So coming to this one, you are going to have your a sub 1 plus your b sub 1, but here you're going to have x minus, you're supposed to say x1, but what is our x1? We already given our x1 as 1, so we have to put it there, plus c naught. Why am I writing c naught? This is actually supposed to be c sub 1. Okay, sorry for that. So this is supposed to be x minus 1 to the power 2 plus here this would be d sub 1, okay, x minus 1 to the power 3. So the conditions that we have, okay, this is if your x, okay, is within 0 to 1, then this is when if your x is 1 to 2. Okay, I'm just getting these from these values that I have here. Okay, so we pretty have what we are like the first part of what we are looking for. So let me highlight what we have to do and why we are doing what we will be doing. So all in all, when the question is asking for you to construct a natural cubic spline, it's in this form. There's a generalized form, but of course I wasn't really including more like your x minus x naught, because we already know what our values are. So what we are looking for is the fact that at the end you are going to have your s of x is equals to some functions where you have your s naught of x is equals to some function here, s sub 1 is equals to some function here as well, which is partially what we have here. I say partially because remember we have these coefficients here. We have all these 8 coefficients. So our job is just to look for these coefficients, starting from a naught to d naught, as well as a sub 1 to d sub 1. If we have those coefficients, meaning we have constructed the what? The natural cubic spline that interpolates this data that we are given. So how do we do it? There are about 4 important steps that we are going to take. Okay, so the first one being, I'm going to highlight it this way. You have to interpolate. Okay, you have to, more like, let me say it this way. Apply. Okay, you have to say apply um, interpolation conditions. Okay, interpolation conditions. That's the first thing that you have to do. Apply the interpolation conditions. What do I mean? It simply means apply the interpolation condition for s naught of x on 0, 1. What does that say? It simply means you substitute for 0 here, again substitute for what? Substitute for 1. You do the same for the second one. You substitute for 1 as well as what? As well as 2. So what we are going to do is that we are going to write it this way. We are going to say s naught of 0. Okay? What is this equals to? Remember, s naught of 0 is the same as f naught. I mean, is the same as f of 0, which is equals to what? 0. Okay, that is equals to 0. So it simply means our s naught is equals to 0. Why am I getting the 0 from? It's this output here. What I'm simply doing is that when I have an input which is 0, my output is what? Is a 0. So we have a 0 there. Okay, so that's what we have done. We have evaluated for this part. Okay, because this part is equals to this part here. Similarly, this part here is still, when you try to evaluate for 1, it will be equals to what? It will be equals to 1. So now, we have only evaluated for s naught. I've not yet evaluated for this part here. So if you plug in 0, 0, 0, you have x here, you just end up with what? Zeros, and this will be just what? A naught there. Okay, so here you end up with a naught. So remember to say this is supposed to be equated to 0, which is the outcome, but it is also equated to this, which is, after we evaluated, we ended up with what? We ended up with a naught. Okay, so what does this tell us? It tells us that our a naught is equals to 0, because when you equate a naught to s naught of 0, it is also equals to 0. So that's the first part. Second part, it is s naught now evaluated at what? At 1, which is this one here. No coincidence, it's just that same one that is there. So this now is equals to what? Remember, when you evaluate, this s naught here is the same as this one here. Okay, it's like they are equals to each other. So what is the outcome? It's more like when I plug in 1 here, it's the same as f of 1. What is our f of 1? It's equals to 1. So this is equals to 1, like that. Okay, so now let's evaluate for this part after we substitute with 1. So plug in 1, 1, 1 here. Okay, so what will this be equals to? So this is just going to be a naught plus b naught plus c naught plus d naught, like that. Okay, but remember, our a naught, we have found that it is equals to what? It's equals to 0. Hence, we don't need to include it. So we can just leave it out. And this here is supposed to be equated to what? To s naught of 1. And what is our s naught of 1? We have found that it is equals to what? It's equals to 1. Or we are already given. Okay, so allow me to write this like this. It's b naught plus c naught plus d naught is equals to 1. So allow me to indicate this as equation 1. I'm just going to put 1 there, like that. Okay, so let's go to the second one. This is now s sub 1, because we have evaluated this one on both the points. So now let's evaluate the second one. So we are going to evaluate s sub 1 at what? At 1. What is the outcome? Like the value is still what? Is still 1. So we put a 1 there, like that. So now in this one, it simply means now, like, we have evaluated for this one. Now you have to evaluate for what? For this one. So if you plug in 1 here, this would be 0, this would be 0, and that would be 0, and you just end up with a sub 1. So if you equate this a sub 1 to what? To s sub 1 of 1 is the same as equating it to what? To 1 as well. So this tells us that our a sub 1 is equals to 1. I'm not going to name this as some equation 2 or something, because that's just like, it already gives me what I'm looking for. Okay, so now let's evaluate for s sub 1 at the other point, which is a 2. Okay, so if you put s sub 1 of 2 is the same as f of 2, and what is our f of 2? Our f of 2 is equals to 2. So in here now, also plug in 2. Okay, so this is just going to be our a sub 1 plus, if you plug in 2, that's just going to be b sub 1, same as c sub 1 plus d sub 1. Okay, but we know what our a sub 1 is. Our a sub 1 is equals to 1. So what do? We can just plug in a 1 there. So this is plus 1. But remember, this is supposed to be equated to this one. And what is that? That is equals to 2. That is equals to 2. When this comes the other side, you're going to subtract. So meaning this whole thing is just equals to 1. Okay, this whole thing is just equals to 1. So let me just move it here. So this is just equals to 1. And allow me to name this as our equation 2. Equation 2. So one thing that we have already found is the fact that our a naught is equals to 0, our a1 is equals to 1. So meaning, among the 8 coefficients that we are looking for, we already have 2 of them, so about 6 are remaining. Okay, so what's the second thing that follows? So what I'm going to do, because of space, I'm going to erase this part. I'll still bring it up afterwards. Okay, or you can just write it down just to remember the way it is. Okay, do I have to? No, let me leave it. Okay, let me leave it, but I'll have to save these equations that I have, so maybe I can just get rid of this part here. Okay, I can get rid of that part, so meaning I can write what I have, the equations that I have b naught plus c naught plus d naught is equals to 1. Then I also have b sub 1 plus c sub 1 plus d sub 1 to be equals to, is it equals to 1? Yes, it is equals to 1. So we said we have allowed this to be equation 1 and this to be equation 2. Okay, so let's get rid of this part so that we use it as our working space. Okay, so now we have applied the interpolation conditions. What's the second thing that you need to apply? What you need to apply is the first derivative. Okay, you have to apply the first derivative. And what is that first derivative, and where do we apply it? Okay, so this first derivative, it is applied at the point of intersection, like the point at which these two are intersecting. Okay, so the point at which those two are intersecting is this one here. They're intersecting at 1. So that's where I need to apply the first derivative. So when you differentiate the first one, like when you differentiate this one, it simply means your s prime of s naught, s naught prime, if I was to call it like that, of x is just going to be equals to, when you differentiate this, your a naught to be 0, so just going to have b naught plus 2c naught, am I doing the right thing? 2c naught x plus 3d naught x squared, like that. Okay, so you have to evaluate this at the point of intersection of the two splines. So if you plug in 1 here, what will this be? So this is just going to be, you have b naught plus 2c naught plus 3d d naught. Let's now differentiate the second one. So this is going to be s prime of that. This is going to be equals to b sub 1 plus 2c sub 1 x minus 1 plus 3d sub 1 x minus 1 to the power 2. I was just using the chain rule. So if you substitute, you put a 1 here, okay? This is just going to be b naught, because when you put 1 there, like when you plug in 1 here and 1 here, that's going to be 0. So you just have b sub 1. So what you need to do is to equate this one to this one. So it simply means your b sub 1 is equals to b naught plus 2c naught plus 3d naught there. Okay, that's what we have. And allow me to name that as equation 3. So I'll just write it here as our b sub 1 is equals to b naught plus 2c naught plus 3d naught, and we say we let this be equation 3. Okay, so now let's go ahead and look for equation 4. Okay, let's go ahead and look for equation 4. So we have gotten our equation 4 from the first derivative. So equation 5, we are going to get it by applying the second derivative and evaluate at the point of intersection, okay, of the two splines, just similar to the first derivative. So when you differentiate this for the second time, it will be s prime prime, it will be equals to, this will just be 2c naught plus 6d naught x. Okay, then for this one to be s prime prime, it will be equals to 2c sub 1 plus 6d sub 1 x minus 1. Then for this one, if you substitute 1 there, okay, if you plug in 1 here, this is just going to be 2c naught plus 6d naught. Is it? Yeah. Then for this one, it will be, when you plug in 1, this is just going to be 2c sub 1. Why? Because when you plug in 1 here, you're just going to get a 0. So it simply means you're going to have 2c sub 1 is equals to 2c naught plus 6d naught. And if you simplify this, you divide both sides by 2, your c sub 1 is going to be equals to c naught plus 3d naught. And allow me to name that as equation 4. So c sub 1 is equals to c naught plus 3d naught, and that is my equation 4. Okay, so now what else do we have to do? Okay, what else do we have to do? So I'm going to now apply. We have done 3 steps so far. The first one was applying the interpolation conditions. Second one was applying the first derivative. Now, the third one was applying the second derivative. Now we are going to apply the fourth part, which is the boundary conditions. Okay, we're going to apply the boundary conditions, and we're using the boundary conditions. We're going to use the second derivative. So I'm going to save my second derivative right here. Okay, I'm going to save my second derivative. So we are now applying the boundary conditions. Okay, that's our boundary conditions. Let's now try to see what this means. So for our boundary conditions, what I mean, or what it means, is that you're going to apply the boundary conditions, like you're going to use x naught for what? For s naught of x, like the second derivative rather. Okay, then you're going to use x sub 1 for what? For s sub 1, like the second derivative. Those are the boundary conditions. Is it s sub 1? No. It's x sub 2. Okay, which is this one here. So it simply means for the boundary conditions, you're just using x naught, which is equals to 0, and x2, which is equals to a 2. That's what you're going to do. So Here, if we now do the substitution, since I already have the second derivatives, I already got them from the previous step that we took. Here we are going to say s prime prime. This is s naught, by the way. S naught prime prime. If you plug in 0 here, what are you going to get? If you plug in 0 here, that's just going to be a 0, so you just end up with a C naught. Okay, and by the way, these are supposed to be equated to 0. So these are not equating each other, they're just supposed to be equated to 0. So it simply means here our C naught is equals to 0. So we have found another point, which is pretty interesting. So let me just erase this part. We have actually found another point, and that point is the fact that our C naught is equals to 0. So how many points remaining? How many coefficients remaining? 5. We are looking for 8 of them, but we're just remaining with 5. Okay, so let's evaluate for this one. S prime prime, S sub 1 prime prime of the other boundary condition, which is 2, and we are equating this to 0. So substitute here, that would be 2c sub 1. If you plug in 2 here, just going to end up with 6d sub 1, and there is a plus here, by the way. So it simply means you have your c sub 1 plus 6d sub 1 is equals to 0. Okay, is equals to 0. Then allow me to name this as equation 5. Okay, allow me to name this as equation 5. So it's 2c sub 1 plus 6d sub 1 is equals to 0. We say this is equation 5. So we have 5 equations there. So do we have everything that we need to solve what you are looking for? Perhaps. Okay, perhaps we do. So let me just erase this. So now let's start to simplify everything that we have here. Okay, so what I'm going to do is that I'm going to get equation I'm going to equate equation. What equation am I going to equate to? So by the way, since I found that c naught is equals to 0, I can actually simplify this one. Okay, I can simplify it. It now becomes just like b naught plus d naught is equals to 1. So let's try to simplify it just here. Okay, we simplify it just from here. Okay, so we just remain with d naught is equals to 1, because c naught is equals to 0. Okay, so what do we do now? So from here what we can do is that if you look at this part, okay, if you look at this one here, I'm able to simplify it. Okay, I'm able to simplify it. What I'm able to do is that I can write this in terms of c sub 1. I'll say c sub 1 is equals to there's a 2 here, so that would be negative 6d sub 1. So if I divide my c sub 1 will be equals to negative 3d sub 1, which is I'm still going to take it as my equation 5. Okay, I'm still going to take it as my equation 5. So I'm just going to erase this one. I don't know why I didn't do that in the first place. Yeah, so that would be c sub 1 is equals to minus 3d sub 1. Okay, so from there I can now start to simplify everything that I need. So I'll try to use equation 5. Okay, I'm going to try to use equation 5. What about this one? This one is also able to be simplified. I will try my level best to simplify as anything as I can, because this is a 0, right? So we're just going to remain with 3d naught. Okay, so that's our equation 4. So it's a 3d naught, like that. So now what we are going to do is I'm going to use this one and this one like for simplicity, I'm going to equate them because I have C sub 1 and C sub 1 here. So what does this tell me? It tells me that to say 3D naught is equals to minus 3D sub 1. Okay, and this can actually be written as just D naught is equals to minus D sub 1. Okay, which is a very, very important part. I'm going to use it a lot. Okay, so what follows? So this D naught is equals to minus D sub 1. I'm going to substitute it in equation I'm going to substitute it in equation 2. Where's my equation 2? It's this one here. Okay, I'm going to substitute it in my equation 2. Is it equation 2? Let me see. Actually, for I'm going to save this one for simplicity. I'm going to save this one for now. Actually, what I'm going to do is that I'm going to get equation 5, and then I'm going to substitute it in equation 2. Okay, so instead of substituting this one, I'm going to use equation 5. So I'm going to say I'll substitute 5 in equation 2. How does this become? Equation 2 is equals to this one here, then substitute 5. It simply means where there's C sub 1 here, I'm going to put this one. So this is going to be like a B sub 1 plus, but that will actually be a minus 3D sub 1 plus D sub 1 is equals to 1. What does this give me? This gives me B sub 1 minus 2D sub 1 is equals to 1. Okay, is equals to 1. So I'm going to save this. I'm going to save it. I'm just going to write it here. B sub 1 minus 2D sub 1 is equals to 1. What other substitution am I able to make here? Okay, what other substitution am I able to make? So looking at equation 1, okay, looking at equation 1 the way it is, which is this one, I can choose to make B naught the subject of the formula, meaning I can say B naught is equals to 1 minus D naught. 1 minus D naught. This is what I have. Okay, I've just chosen to make. You can actually also do like make D naught the sub of the formula. So what do I do? Then I'll substitute it in equation. What equation can I use? Equation 3. Okay, so I'm going to say in equation 3 my B sub 1 is equals to my B naught, but in place of B naught I'm going to put 1 minus D naught plus 2C naught. Okay, 2C naught, and actually this one we can get rid of it. Okay, we can get rid of it because there's C naught, and our C naught is equals to what? Our C naught is equals to 0. So we don't have to bother ourselves with that. Then that would be what? That would be plus 3 D naught. So our B sub 1 will be equals to 1 plus 2 D naught, like that. Okay, so we are getting close. So here this is going to be, I can write it as B sub 1 is equals to 1 plus 2 D naught. Okay, what else are we able to do? What else are we able to do? Then one thing I'm able to do is that for simplicity, remember I have a sub 1 here, then I have a sub naught. So what do? I know what D naught is equals to. D naught is equals to what? D sub 1. So for this one here, what I'm going to do is that where there is D naught, just substitute D minus D sub 1. So this becomes a minus D sub 1. Remember, it was B sub 1 is equals to 1 plus 2 D naught. I've just done like B sub 1 is equals to 1 plus 2 open bracket minus D sub 1. So I've ended up with that. Okay, then what else am I able to do? So I have this B sub 1 here. Okay, I have that B sub 1, and I have this B sub 1 here. Okay, so and if you look at this, you can actually make this one the sub of the formula, then, or in place of this you just substitute. So that's just going to be like, in place of this b sub 1, substitute this b sub 1. Let's see what we end up with. You're going to have a 1 minus 2d sub 1 minus 2d sub 1 is equals to 1 there, like that. This one and that one cancels out. You're going to have minus 4d sub 1 is equals to 0. What does this tell us? It tells us that our d sub 1 is equals to 0. Interesting. We have another point, another coefficient. D sub 1 is equals to 0. So we are looking for 4 more. Okay, so the fact that I know what my d sub 1 is, I can find my b sub 1. So I have my b sub 1 is equals to, I can make it, yeah, just from here, it will be 1 minus 2 d sub 1. If you plug in 0 here, it simply means your b sub 1 will be equals to 1. B sub 1 is equals to 1. Okay, how many? 5, 3 more. So from here, I can get my d naught. So d naught is equals to minus d sub 1, meaning it's also equals to 0. So d naught is equals to 0 there. Okay, that is equals to 0. So what else are we able to get there? Okay, so about two are remaining. What about our c sub 1? Our c sub 1, look at this. Our c sub 1 is equals to 3d naught. If you plug in d naught, it simply means your c sub 1 is also equals to 0. So which other one is remaining? We have our a naught. We don't have our b naught. Okay, we don't have our b naught yet. So remember, b naught is equals to, from here, b naught can be written as 1 minus d naught. So if you plug in 0 here, our b naught is just going to be equals to 1. Okay, so now we have everything that we need. Let's get to us now constructing the final answer that we were initially looking for. Okay, so is there anything that we have to keep in mind here? Let me see. Do we have the correct value for a sub 1? Yeah, it's basically okay like that. Yeah, it is okay. So it simply means now what is remaining is just for you to substitute here. Substitute x naught. What is our x naught? Is a 0. B naught is a 1. C naught is a 0. This one is a 0. So it simply means you have like our s of x is equals to your s naught of x is equals to what do we have here? If you substitute everything here, this would be 0, that would be 0, and that would be 0. So just remain with what? With x. Then if you substitute here for the second one, your a sub 1 is a 1. Okay, your b sub 1, we have found that is also 1. So when you multiply, it's just like plus x minus 1. Your c sub 1 is 0. Your d sub 1 is 0. So 1 minus 1 is 0. So your s sub 1 of x is just equals to x as well. And that is for the, remembering that the condition is where x is between 0 and 1. Then here is where x is between 1 and what? 1 and 2. And this is basically the cubic spline that we were constructing. So just an outline of what we have done. We have applied the interpolation conditions, the first derivative, second derivative, as well as the boundary conditions. Then we have simplified these equations that we were forming. Okay, so that's all in this video. Thank you very much for watching.